In this video, we're solving high-degree polynomial equations. So let's solve x to the fourth minus 4x to the third plus x squared plus 12x minus 12 equal to 0. We're solving an equation that's equal to 0. So essentially, we're finding the zeros of the polynomial. To find the zeros of a polynomial, we want to get it in factored form and then set each of those factors equal to 0. We want to list out possible rational zeros so we can start testing numbers that would make sense. Our possible rational zeros are all plus or minus, and we're taking the factors of the constant divided by the factors of the leading coefficient. The factors of our constant include 1 and 12, 2 and 6, 3 and 4. And then we're dividing that by the factors of our leading coefficient, which is 1. We'll simplify this list. We know everything's a plus or minus. And since the only number in the denominator is 1, all those numbers in the numerator over 1 will end up being those numbers in the numerator. So there's our possible rational zeros. I always start by checking 1. A shortcut to checking 1 is to just add up the coefficients. I just look at my positive ones and my negative ones. If I add up these coefficients and it's equal to 0, then I know that 1 is a 0. So I got a positive 14 and a minus 16. That's not going to give me 0. So right away, I know that that 1 is not a 0. So I'm not going to check 1. Pick another number. I think I'm just going to go right down my list. Let's check. Well, I don't want to check the big numbers to start, so let's check 2. Synthetically dividing 2 in. Let's see what we get here. How nice, we got a remainder of 0 right away. Since we have a remainder of 0, we know 2 is a 0, and that 0 of 2 can give us a factor. So let's start factoring our fourth degree polynomial. The factor we get from our 0 of positive 2 is x minus 2. Our next factor is going to be cubic, since we started with a fourth degree. So that's x to the third minus 2x squared minus 3x plus 6. All this is still equal to 0 because we started with an equation. Since my cubic factor has 4 terms, every time I have 4 terms, I try to factor it by grouping. This time, factor by grouping is going to work. Look, we have a common binomial factor there. So there's my original factor, x minus 2. Now I'm going to have a second factor of x minus 2. That's the common binomial factor I'm factoring out. And then we have x squared minus 3 equals 0. Notice that we have a factor that shows up more than once. If we were to just not have factored by grouping and continued checking zeros, we would not have found that second 0 of 2 unless we check 2 a second time. So if you're going through your list of possible rational zeros and you're like, oh my gosh, I've tried every single one of them and nothing's working, try retesting a 0 that did work, because you might have a factor with multiplicity. To that end, I would check the factor by grouping every time because maybe that can help avoid that situation. Continuing to factor, well, I don't have to check zeros anymore because my largest factor is quadratic. So I'm going to try to factor that by traditional technique. Since 3 is not a perfect square, I'm not going to be able to factor this. Our ultimate goal isn't to get it factored. The question asks us to solve the equation. So we don't actually have to get this factored all the way down to linear factors. At this point, we can just apply zero product property and solve each of these equations individually. Our first two equations give us the same solution of 2. Our third equation is quadratic. Square root property would be the easiest technique to apply here. We get x to be equal to plus or minus the square root of 3, and x equals 2.